Good morning, everyone. I welcome you all for the next lecture series. I think for the last class, you all remember we have discussed about the architecture of 8086. So normally 8086 consists of two functional units. One is execution unit and then bus interfacing unit. Bus interfacing unit helps to get the data from the memory and it is placed in the queue. Based on the queue instructions is executed by the instruction execution unit, and segmentation registers are available in the BIA unit. So it is helped to create the 20-bit address lines. And for the execution unit, it consists of ALU, apparent flag, and general purpose registers. So just you remember all the informations. Already told you. Arithmetic logic unit is to perform the arithmetic and logical operations. Flag, there are 16-bit flags are there. The condition of the result will be stored in the flag, and there are type of registers are available. A register, B register, C register, and D register. So these are used by the user. That is why it is called as general purpose registers. So now we are going to discuss in this class in detail about the execution unit and BI unit. So execution unit, it gives the instruction to BIU starting from where to fetch the data and then decode the execute those instructions. Function to control operations on data using the instruction decoder and ALU. EU has no direct connections with the system buses. It performs operations over data through BIU. And ALU means handles all arithmetic and logical operations like addition, subtraction, multiplication, division, OR, and NOT operations. So stack pointer register, it is a 16-bit register, holds the address from the start of the segment to the memory location where a word was most recently stored on the stack. So next one is flag register, 16-bit register that behaves like a flip-flop. That is, it changes its status according to the result stored in the accumulator. And it has 9 flag. They are divided into two groups. One is conditional flag and then unconditional flags. So 9 flags only we are using. The remaining 7 flags are not used in the condition. So conditional flags represents the result of the last arithmetic or logical instructions executed. So control flags controls the operations of the execution unit. So flag register for the conditional flag, carry flag, auxiliary flag, parity flag, zero flag, sign flag, and overflow flag. So carry flag means it indicates an overflow condition for arithmetic operations. And auxiliary flag, when an operations is performed at ALU, its result in a carry borrow from lower nibble, that is D0 to D3 to upper nibble D4 to D7. Then this flag is set. So parity flag is used to indicate the parity of the results. So odd parity or even parity. So zero flag set to 1 and the results of arithmetic or logical operations is 0, else it is set to 0. And the sign flag, it holds the sign of the results. That is, if your result is in the minus or negative, then when the result of the operation is negative, then the sign flag is set to 1, else 0. So next one is overflow flag, represents the results when the system capacity is executed. And then is conditional flag. So there are 3 type of flags we are going to discuss. One is trap flag, interrupt flag, and then direction flag. So trap flag used for single step control and allows the users to execute one instruction at a time for debugging. If it is set, then the program can be run in a single step mode. So interrupt flag, it is an interrupt enable disable flag that is used to allow prohibit the interruption of a flag. It is set to 1 interrupt enable condition and set to 0 for the interrupt disable condition. Next one is direction flag. So it is used in the string operation when it is set. Then the string bytes are accessed from the higher memory address to the lower memory address and vice versa. So next one is general purpose registers. So general purpose register consists of 8, that is AHAL, BHBL, CHCL, DH and DL. The valid register pair AHAL and BHBL, CHCL and DL. It is referred as AX, BX, CX and then DX respectively. So AX register, it is also known as an accumulate register. It is used to store the operands for arithmetic operations. So next one is BX register. It is used as a base register. It is used to store the starting base address of the memory area within the data segment. And then CX register, it is referred to as a counter. It is used in loop instructions to store the loop counter. And DX register is registers. This register is used to hold the input-output address for the IO instructions. So the remaining functions we are going to see in the next lecture series. So thank you all. See you in the next lecture.